Thank you so much, Susan. And thank you all for joining us today. So, the topic of the day of this brief 1-hour webinar is security requirements engineering. We will only begin to touch this topic in the brief time we have, as it's a very broad and complex subject. But the goal is for you to walk away with an idea of the artifacts that underlie the definition of security requirements, a basic understanding of how to think about designing security requirements, and familiarity with a model called the square process model for extracting and defining requirements in real applications. So with that, we will get started. We're going to begin with an overview of what is requirements engineering before we get to security requirements engineering. First, why is it important? There are a number of statistics out that show there are exponentially higher rates of defect in systems that do not for whom the designers do not invest time in defining and eliciting strong security requirements and functional and operational and safety requirements at from the design, the beginning of the systems engineering process. There is an exorbitant cost to rework and address these defects after deployment of the system versus the cost savings that are shown from addressing these needs a priori from the design phase of the systems engineering process. So why should you care about requirements engineering? Because it is absolutely critical to the success of designing a resilient and robust system that performs in the face of failure and faults. So let's see. Requirements are the top causes of why projects go significantly over budget and over schedule, why projects often get canceled or reduced in scope because requirements were never defined that specify the intended functionality of the system to guide a structured software development process and systems engineering process. Development teams, in the absence of software requirements, lack metrics and measurables to test and validate their progress to, so they lack quality applications. And products that aren't designed using security requirements are often not significantly used once they are delivered. So it's important to realize that elicitation of requirements, security requirements and otherwise, requires input from multiple stakeholders, not just software developers, but also potential users of the system and customers of the system, people who will be implementing it for other people to use as their risk model is affected and depends very much on how the system is intended to be used. So this is very important stuff. A concept we want to go over now is called software assurance. So what is software assurance? The level of confidence that software is free from vulnerabilities, either intentionally designed into the software or accidentally inserted during the life cycle, and that the software functions in the intended manner that it was designed to function. Critical parts of software assurance include trustworthiness, which again ties back to reliability and confidence that the system was designed according to requirements, that weaknesses don't exist, and that the system is fault tolerant of failures and other environmental conditions that may introduce chaos into the operation of the system. Another critical aspect of software assurance is predictable execution, which again is very related to the previous statement, that when software is executed, it performs as intended. There is often difficulty, we talked about in a previous webinar, about the ability to have full knowledge of all the different states that exist that a piece of software or any system can be induced into. So without defining security requirements, it is extremely difficult, if not impossible, to have a full representation of the state diagram of software, which means that it is more than likely that states exist and can be induced to make your software behave other than how you intended, whether that's maliciously or whether that's to cause a failure. So software assurance is the goal of defining useful software and security requirements. The life cycle focus of software assurance looks like this. We're going to be focusing today exclusively on the requirements and acquisition parts of the software assurance life cycle. We're going to talk about abuse cases and misuse cases, and we're going to talk about artifacts. We will not get into the rest of the architecture and design, testing, validation, etc. As that would take much longer than the brief time we have today. So now to actually put a definition to requirements engineering. It is the process of establishing the services that the customer requires from a system and the constraints under which the system is intended to operate. Requirements can be both functional and non-functional. Ergo, the functional requirements describe how a system is supposed to perform, what functionalities it's supposed to offer to its users and administrators. Non-functional requirements are constraints in terms of not necessarily functionalities that are offered to the user, but say design considerations and architecture choices that are not visible to the end user. So it's important to take into consideration both functional and non-functional requirements when you're designing systems, as functional requirements are going to be most important to your user base, while non-functional requirements are going to be most important to guaranteeing the resiliency and fault tolerance of a system, as well as the ability to know and have visibility over the state space that a system can be introduced into. So that's what requirements engineering is. Now, what is a requirement? Well, a requirement, they can range from low-level, very specific implementation details. Say the software will provide the ability for the user to log into a portal using Shibboleth, or there may be a high-level abstract statement that says users will be provided the ability to log in. This kind of duality is inevitable, as certain requirements might serve both a high-level abstract requirement and a very low-level requirement. So these all lump into requirements. We're going to talk about this more. Here's the actual definition of what a requirement is: a statement in natural language that can be substantiated by other contextual information like diagrams of the services and components of the system and the operational constraints between interfaces and components within that system. So the requirements definition.
Hi there, I hope you enjoyed that last clip. My name is Michael Maludis, and if you'd like to watch the full 60 minutes of that last webcast, while also gaining complete unlimited access to our entire library of IT learning, simply visit our subscribe page at greatpro.org/subscribe. Unlimited annual access is $199 per year, but if you use the coupon code LEARN2EARN, you can drop that membership fee to just $149. That's less than $13 per month for unlimited access to over 1,000 hours of on-demand career development, covering the entire spectrum of IT management best practices, including business analysis and requirements, software development, quality and testing, risk management, process improvement, project management, and even digital transformation. But your membership doesn't just give you unlimited access to our vast learning library. You also get free access to our mobile app, as well as direct access to our network of over 300 of the world's leading IT consultants, all of whom are dedicated to putting practical knowledge at your fingertips so that you can learn more and earn more. I hope you will join me in becoming a member of the Great IT Professional and advancing your career with us. And if you're on YouTube, don't forget to hit that subscribe button above so that you get notified whenever we publish new free webcasts each week of the year. Thank you for your time and best wishes for your continued success.